Okay, let's just briefly mention nuclear transmutations. What we've been talking about earlier with radioactivity is where we have our atom and it spontaneously emits a particle. With nuclear transmutation, the first that was done was by Ernest Rutherford, in which he took nitrogen and he bombarded it with an alpha particle. And what he found out was that you produce hydrogen and oxygen. So this is the first time where it's more synthetically made. In the condensed notation, we write down our starting atom, write down the particle that we bombarded it with, we write down the particle that was emitted, and the resulting new element. So this is the condensed notation for that. We actually have now made a series of new elements, and that's caused by basically bombarding with neutrons from bombarding with heavy nuclei. So you hear series that the elements past uranium are called transuranium elements, because when you have an atomic number greater than 92, a lot of them have been made through nuclear transmutations. So that now that you know this, let's try to write the condensed version of this nuclear transmutation. I take oxygen 16, I bombard it with a proton, and what I get is nitrogen 13 and an alpha particle. Okay? You can, neon, excuse me, an alpha particle is helium. You can see 2 plus 7, 1 plus 8. Both sides have the equal number of protons. And then when I look at my mass numbers, 4 plus 13 is 17. 1 plus 16 is 17. So this is balanced. We write down our starting nuclide. We bombarded it with a proton. And the emitted particle is my alpha particle, and the new product is nitrogen 13. When we talk about transmutation, we need to talk about accelerating charged particles. So we're talking about particle accelerators, and we have both the synchrotron, okay, so we have linear ones, like up in Berkeley, where it's Livermore Laboratories, or Chicago has a cyclotron. Cyclotron. So we know how to spell today. So these accelerators, the linear accelerator, basically you have an alternating voltage sources, which basically propels your particles at a high velocity, and then it basically gets targeted and crashes into your target. And then we analyze at your target with the new particles that are made, what they are. In cyclotron, the pathway is circular. Okay, and then we'll move on to half-life.